Alright, the drone is all wired up. It's time to do the full Betaflight setup. The first thing I want to do is make sure we get a good cooling solution for this drone while we set it up, because the setup process is going to take a little bit of time and I don't want the analog VTX there to overheat while the VTX is powered on. What I've made for my drone builds is this little 120mm PC cooling fan, which I've made into this kind of drone stand, so I can just set my drone on top of it. Now the fan is on and the drone is being cooled. You can also just point a normal table fan at the drone if you'd like. First, let's open up Betaflight Configurator and let's plug in our flight controller to our computer. It's asking us for custom defaults, so I'm just going to hit yes for that, and hopefully our flight controller will be recognized. The accelerometer is not calibrated, that's fine. Okay, it looks like my cable is a little bit iffy. I needed to prop it under this little tape measure to get it to connect, so I definitely recommend getting a better quality cable than I have here. But anyways, it looks like Betaflight has successfully recognized our drone right here. And unfortunately, at the top left, we can see we're on firmware version 4.4.2, which isn't the latest version. So let's go ahead and upgrade that. So to upgrade that, I'm going to take a close look at this target at the top left, and it says the flight controller we have is the Omnibus F4SD. I'm going to remember that. Let's go ahead and hit the bootloader DFU button to put it into DFU mode. And at the top right, you can see it was successful. It says DFU STM32 bootloader. If that doesn't pop up, if instead you see something about like device error, like device not recognized, that means you have to run Impulse RC driver fixer in order to install the DFU driver. I've already run that on my computer, which is why it says DFU. So I'm going to hit update firmware. And here we can select the proper firmware. Because we're in DFU mode, we can't auto detect the board, which is why we remember the board name, Omnibus F4SD. It auto selects the latest firmware, which in this case is 4.5.1. And we could hit load firmware online and then flash firmware. Now we just wait for the firmware to flash. Alright, it says the configurator has successfully detected and verified the board. So let's go ahead and connect. It says the accelerometer isn't calibrated, that's fine. Let's go ahead and calibrate that real quick. And at the top left, we can see that the firmware update was successful. We're on the latest 4.5.1 Betaflight. So great, we successfully updated the firmware on the flight controller. While we're here, let's bind our Express LRS receiver to our transmitter. I'm using the binding phrase method, which means I set a binding phrase in the transmitter and I send a binding phrase in the receiver, and as long as that single phrase or word is the same, it'll connect to each other automatically. I've already entered my binding phrase on my transmitter, and now we just have to do it on the receiver. Because this has been plugged in for more than 1 minute, the light on the receiver is flashing very fast, which means it's in Wi-Fi mode. So we can go ahead and go right over to our Wi-Fi connections and connect to Express LRS RX using the password Express LRS. Next, we can open up our web browser and navigate to 10.0.0.1. And so we've connected directly to the Wi-Fi server of that receiver. And here we can enter in a binding phrase. So my binding phrase is pineapple. I suggest you pick your own unique word. Please don't use pineapple, that's my word. And then let's hit save. All right, so that's the first step of the Betaflight setup complete. For these next steps, we want the entire drone powered on. So I'm gonna go ahead and I'm gonna disconnect the drone. Next, we're gonna power on the drone with a battery. And just to make sure, I'm gonna plug it in through a smoke stopper first, just to make sure nothing's gonna explode. So we have the green light, that's good. And if we plug it in, it should continue to be green. Yep, so green light continues to stay green. So it looks like we have no shorts in here. So I'm actually gonna unplug this again. And we're going to plug it in without the smoke stopper, because we will be spinning up the motors to test these, and the smoke stopper will not like that. So the smoke stopper is only used to check for shorts. For everything else, we will not be using the smoke stopper. Anyways, let's plug in the battery directly. Make sure the fan is positioned over the VTX, because the VTX could be getting hot. And now only once the battery is plugged in, then we're gonna hook up the USB again. Oh, and don't forget to turn on your radio. And now that the radio is on, you can see that the radio is connected to the drone and we have a solid light on the receiver. Okay, so while we're here, let's go ahead and set up the receiver first. So we're going to go over to ports, and we set our serial receiver to UART 6 in this build. So we're going to hit serial receiver, check mark yes to that. We're going to hit save and reboot. Next, let's go over to the receiver tab and make sure serial via UART is selected, and make sure Crossfire is selected as the receiver provider, because our Express LRS receiver uses the Crossfire protocol. And now we can jiggle the sticks and see that we do get a response. Great. So our main sticks works. Now we have to set up our modes. So for Express LRS, you always want aux 1 to be your arming switch. So I have it set to this top right button on my radio. So 2000 on aux 1 is armed. Disarmed. 1000 is disarmed. And then the other important mode is your flight mode switch, your angle mode or acro mode. And I have that on aux 2 on this little rocker switch here. Angle mode. So for aux 2, 2000 I want angle mode. Acro mode on. 1000 I want acro mode. So let's go over to the modes tab and set that up. So we're going to do add range to arm, and I'm going to set that to aux 1. And we want the upper range of that. And angle mode, I'm going to add range to that. Set that to aux 2 and set that to the upper range. Now we hit save, and now we can test real quick. If we arm, we can see it goes to arm, and if we hit angle mode, it goes to angle mode. Acro mode on. So that's great. That's all of the receiver setup we need to do so far. The next thing I want to do is I want to test the motor order and the motor direction. And so for this part, you want to double check to make sure that you don't have the props installed on your drone, because we will be spinning up the motors. So for safety, you want the props to be completely off. Let's go over to the motors tab. So the first thing we want to do is we want to make sure that the motor order is correct. So we can see on the little diagram, you can see 1, 2, 3, 4, the motor order. So that means it'll be 1, 2, 3, 4. We just want to make sure that what Betaflight is thinking it's doing is the same thing that we have set up here. So let's go over to reorder motors. I understand that the props are off, and let's start the wizard. So we can see here this motor is spinning, so that's the bottom right. You can see this here is spinning, so that's the top right. We see this motor is spinning, and now we see that motor is spinning. Great. So that's it. We just hit save. The quad reboots. Okay, let's go back to the motors tab, and now we're going to do a really important part, the motor direction. So we want to make sure that the motors are spinning the right way. We want the motors to spin towards this little axis right here. So this bottom right motor is going to spin clockwise like this. This top left motor is going to spin clockwise. This motor here is going to spin counterclockwise. This motor here is going to spin counterclockwise. So let's open up the motor direction wizard. I understand that the props are off. Now we're going to set these individually. So I hit individually. So motor 1, again, we want this to spin clockwise. Let's click this. And I'm going to lightly put my finger on the motor to try and see which way it's spinning, because it can be hard to tell just by looking at it. I can tell by the way my fingers moves, it is spinning clockwise, so that's correct. So we don't touch anything. For motor 2, we want counterclockwise, and looks like that is correct as well. So that's spinning counterclockwise. Motor 3, we want to spin counterclockwise. Oh, this one is spinning the wrong way. So we want motor 3 to spin counterclockwise, but instead it's spinning clockwise. So we're going to hit reverse on that, because it's reverse of what we want right now. So let's hit reverse, and oh, it's spinning the wrong way. So let's actually hit normal, and now it's spinning the right way. It's properly spinning counterclockwise. So I think that should save it properly. Now let's move on to motor number 4. So let's click that. This one should be spinning clockwise, and it is spinning clockwise. Cool. So let's hit close, and so it should automatically save the motor direction. But just to make doubly sure, let's open up the motor direction wizard again and make sure that it saved the motor directions properly. So let's hit individually. And now let's hit motor 1. That's correct. Motor 2. That's correct. Motor 3, this was the problem one. That's correct now, so that's great. That means it did save. Motor 4. That's correct. So all of our motor directions are correct. We're all set with the motors. That's great. Next, I'm going to go over a couple of other things. I am noticing that the CPU load is abnormally high, 45%, and that's probably the PID loop. So let's go over here to the configuration section. And oh yeah, we can see that the gyro update frequency is 8 kilohertz because this has a relatively fast gyro on it, and our PID loop frequency is also 8 kilohertz. And we really don't need it to be that fast. We don't need to do these calculations so blazingly fast. So let's go ahead and actually reduce that all the way down to 2 kilohertz. This slower PID loop frequency is going to put less stress on our CPU. So let's go ahead and hit save. Oh, before we hit save and reboot, let's go ahead and rename our craft too. So this is going to be the 5-inch. So let's name that 5-inch. Let's see if there's anything else we want to do. Maximum arm angle, we want that to be 180, which disables it. This means we can arm and disarm no matter what direction the quad is in, which is really handy if you accidentally disarm midair. Let's go through here and look at our other features. We do want our OSD, but we don't want LED strip because we're not installing any LED strips on here. So we're going to uncheck that, just make sure there's no extra resources being used for that. And then we can hit save and reboot. And now you can see that since we reduced our PID loop frequency from 8 kilohertz to 2 kilohertz, our CPU load has dropped significantly down to 15%. So that's good. Okay, our final step is to set up our video system. And to help me do that, for bench use, I have this little analog receiver, this tiny little 3-inch analog receiver. This makes it really easy to see the OSD live on screen without having to actually take out my goggles. I'm going to set this down here and use this as a reference to set up our OSD. Right now you can see it's completely blank. Our first step to set up our OSD is to set up our VTX control. So let's go over to the port section. We have our data line from the VTX going into UART 3. And this VTX is a smart audio device. So we're going to go over to UART 3 and go over to peripherals. And since this is a smart audio device, we want to select VTX Smart Audio, save and reboot. All right, so now let's go over to our video transmitter tab down here. And we can see here that device ready is true. That's really a good sign, so it means it's reading the VTX properly. It's set up to Smart Audio 2.1 unlocked. Okay, but now our VTX table is empty. We need to upload the correct VTX table for our VTX. For this particular VTX, this Solo Good 1 watt VTX, I've downloaded the file. It's called VTX 1000 milliwatt.json. If you're using a different VTX, you're going to download the correct VTX table for your video transmitter. So I'm going to upload this one real quick. And now we can see down here that it populated the proper VTX table as well as the power values and labels. So you can see we can go from 25 milliwatts all the way to 1 watt. Let's scroll back up and choose my desired band and channel. So I personally like to fly in band A, channel 6. While we're on the bench, we're going to set to the lowest power level 25, and we're going to hit save. And once you hit save, it's at this point that you should be able to see the screen on your monitor. So I had already set up this monitor to channel A6, and we see the video display right here. Now it's time to set up the OSD, so all the little elements on the screen. So let's go over to the OSD tab. So the very first really important thing we have to set up is our video format. We definitely don't want HD. Now, I would say the vast majority of the time, like 99% of the time when you're dealing with an analog system, you want to hit NTSC. So that's what's used in North America, and most cameras will by default just use that. Unfortunately, this really cheap $10 camera will only work on PAL. It took me like hours to figure this out. I was wondering why my OSD wasn't working. It turns out that this camera will only function on PAL. So most of the time, if you're using the average FPV camera, you want to set it to NTSC, but this camera is just a little unique, so we're going to set it to PAL. Let's go ahead and move our warnings over to the middle, and quickly let's just turn on the artificial horizon real quick. I like to fly with this little artificial horizon right here. We're going to try and center this as best we can. This is always the most annoying part of the setup, because the resolution on these analog systems isn't very good, so you can't really get it exactly in the center. All right, that's gonna do for now. Let's hit save and let's hope the OSD pops up now on our video feed. All right, our OSD hasn't popped up on our video feed even though we hit save. So we're gonna do a full reboot. Sometimes the analog OSD chip on our flight controller needs a full reboot in order to properly display the OSD. So I'm gonna hit disconnect in Betaflight. I'm gonna unplug the USB cable first. Then I'm gonna unplug the battery. I'm gonna wait a second.
Telemetry lost.
I'm gonna re-plug in the battery.
Telemetry recovered.
And now we see the Betaflight splash screen comes up. And we see our artificial horizon and warnings. So yeah, that's another kind of annoying thing with the setup. The VTX chip on the flight controller needs a full power cycle sometimes in order for the settings to save. And let's go ahead and connect our USB cable back in. While we're here, let me zoom in as best I can onto this little monitor, because that's the main thing I'm going to be focusing on. Let's go over to our OSD section, and let's go ahead and set up the OSD as best as we can. Because this is set up as PAL, but most of my screens are also NTSC, it's going to be a little bit finicky. What you put on your OSD is up to you. Here's what I like to do. The artificial horizon I really like. Battery average cell voltage. We're going to stick that there. If your ESC has a speed controller, then your battery current draw and milliamp hours draw is going to be useful as well. I've been noticing that a lot of the recent cheap stacks coming out of AliExpress do not have a current sensor. I believe this one I have on the drone right now does have a current sensor, so I'm going to be sticking that there. I also want the timer, so I want on time and flight time, so let's enable those two timers. Then our VTX status over here. Throttle position is also kind of fun. I think that should be it. So let's go ahead and configure these. I want my VTX status up at the top left. I want the throttle position at the top right. I want our timers to be at the bottom, flight time, on time. Okay, and looking at the monitor, this looks like that'll do just fine. So our OSD is set up. I'm gonna hit save. And that actually should be it for the Betaflight setup. Software-wise, our drone is completely ready to go. So we can just do the final steps of buttoning the drone up, putting all the screws, putting all the props on, putting Loctite on all the metal parts, and we should be good to fly.